For this one, we're still on radical equations level 2. And I made sure that there are no solutions here, no solutions. So there's 2 extraneous solutions. What does that mean? It means we have to plug in our answers to see if they work or not. So let's go ahead and deal with this problem and make sure you remember you have to check your answers on when x is under the square root sign. X is under the square root sign, so we have to check our answers. So never do your math on your original problem. So just go ahead and rewrite it. It's not that much work. All right. The first stage is if x is not by itself, or sorry, if the square root is not by itself, then we need to isolate it. The square root is already by itself, so we'll just go ahead and square both sides. That's the opposite of square root. What you do to one side, you do to the other side. So I'll go ahead and square. So I'll square this side. The opposite of square root is square. And I have to do it to both sides. So the whole side gets squared. This is a binomial times a binomial. So that's x minus 3 times x minus 3. So make sure that when you're doing these, every number multiplies to every other term. So every term has to multiply to every term on these. So these first 2 terms have to each multiply to the last 2 terms. All right. Now, usually when we do these, it's a lot nicer and more convenient and more accurate just to do a generic rectangle. So x minus 3 is what we're doing, and x minus 3 is what we're doing. This method is totally okay, but if you're first doing these or you have a tendency to make mistakes, it's a lot easier to do the generic rectangle. So that gives me x squared. This is my side work, so there's no confusion here. All right, negative 3x on this one, negative 3x here, and positive 9. Notice these two usually combine. So all of this equals to x squared minus 6x plus 9. And there's a shortcut here. The more you do these, the more you can kind of see shortcuts. If you just have 1s in front of your x's, then these numbers are added to be the middle number. Negative 3 plus negative 3 is negative 6. These numbers are multiplied to be the last number, positive 9. So we now have the square and the square root undo themselves, and we have 21 minus 10x equals, and I found out x minus 3 times x minus 3 is x squared minus 6x plus 9. Okay, then we want to use the zero product property, which is move everything over to one side so it equals 0. All right, so I'll go ahead and move everything over. So looks like I have the positive x squared here. That makes it easier. So I'll subtract 21 from both sides. And I'm going to add 10x. Add 10x to both sides. So I can do this in the same kind of movement or same stage. It doesn't really change much. So I got 0 on the left. These combine to be removed. Makes 0. That's what I need. X squared hasn't changed. I'm going to go ahead and change my color here so a little bit easier to see. Negative 6 plus 10x. Negative 6x plus 10x is positive 4x. 9 minus 21 is negative 12. Yes. All right. So we're looking for what 2 numbers multiply to be negative 12, add to be 4. So what 2 numbers multiply to be negative 12, add to be 4? See. 2 and 6, right? 2 and 6. We just got to be careful which one's negative. The answer is positive, so the bigger one's positive. The smaller one has to be negative. All right, so this has the form of, it's factoring, so it has binomials in the answer. X and X in front, negative 2 and positive 6. And that doesn't matter the order. Multiplication is commutative, so it doesn't matter. We want to know when this is equal to 0, because that'll give us an output of 0. And we want to know when this is equal to 0. That'll give us the output of 0. So when is x minus 2 equal to 0. Add 2, add 2, x equals positive 2. Hopefully you kind of see that. If I plug 2 in here, this turns into 0. What would we plug into here to make the second one, the second factor, turn to 0? Can you figure it out before I get there? So I want to know when x plus 6 equals 0. Minus 6, x equals negative 6 is what you should have got. So you should have been able to see that if you plug negative 6 into here, negative 6 plus 6 makes 0. So we have our two answers. X equals the set of 2 and negative 6. All right. Well, you got to remember that when we have a square root sign, x is under the square root. X is under the square root. We have to check our answers. We have to check our answers. All right. Some of them work. Sometimes both of them work. Sometimes none of them work. Sometimes just one of them work. So we have to check our answers here. Okay. Go ahead and check both our answers. There's no easy way. You just have to check it. All right. So the first one, I'll check x equals 2. Plugging that in, x equals 2. For the original problem, square root 21 minus 10 times 2 equals 2 minus 3. Okay, simplify. 21 minus 20. And we're checking, this is a question mark. Does this equal it? Does this equal it? That's a negative 1 on this right side. Square root of 1, does that equal negative 1? Does 1 equal negative 1? No, that's false. So let's go ahead and the answer was 2 that didn't work. So 2 does not work. Now I need to test negative 6. I should have just got rid of the parts that I was plugging in. That's fine. All right. Okay, and I'll just go ahead and get everything on my way down here. All right. Now we're going to test x equals negative 6. X equals negative 6. Does that work or not? Plug it into our function. 21 minus 10 times negative 6. Make sure your absolute value goes over it. And we're checking, does that equal negative 6 minus 3? Okay. Go ahead and just simplify. 21, negative and a negative make a positive, so that's positive 60. Does that equal, question mark equal, negative 9? Square root of 21 plus 60 is 81. Does that equal negative 9? Does 9 equal negative 9? No, that's false too. So, negative 6 does not work either. There is no solution here, no solution to this problem. So what do I say? No solution? Let's see. How do they want the answer to be submitted? Do they have it as part of a... Yep, there it is right there. This circle with a slash through it means no solution. Okay, that's not it. Let's see if there's anything else that we can use for no solution. Let's see. No solution, no solution, no solution. Functions. What does the no solution look like? Answers? Nope. Shift. See if any of those are the no solution. Well, I'm not really sure how to represent the no solution aspect. So I'm just going to go ahead and submit it as, let's see, they give me set notation as a possibility. So I'm just going to add the set. So this is the set that has nothing in it. It's the empty set. So I'll see if they'll accept that. Hey, they accepted it. So that's just if there's no answer and they don't give you anything, you say it's the set with nothing in it. Be careful you don't have a 0 here. 0 is a number, so it's the no solution set. It's the empty set. So let's just go ahead and show you what that looks like. So the empty set, this is the empty set, EMPTY, the empty set has nothing in it. There's nothing in here. That's also equal to the null set, which is a circle with a line through it, and that's called the null set. NULL, the null set. Empty set, the null set, no solution. LUTION. There's no solution to these. All right. So that's your final answer. And in this program, I guess they just leave it blank for an empty answer or the empty set answer. So make sure you kind of get these in your tool belt. If none of the solutions work, it's kind of like your empty set. Okay. So yeah, that'll be good for this one.